Until Bloodhound runs under its own power for the very first time, the only data we'll have for how it will behave will have come from complex computer simulations. The obvious ones are for aerodynamic loads, but the engineers have also made thousands of calculations to determine the enormous stresses and strains that the vehicle will have to endure. Pick a point anywhere within Bloodhound and you're never far from a sensor. There are well over 600 in total, and every time the car turns a wheel, they'll produce masses of information. With our new cloud partner, Oracle, we'll be checking the data in real time and using AI to predict where the readings are heading. So long as the data matches our predictions, we'll know it's safe to continue. Any unexpected results, and we'll stop until we've worked out what's happening. All over Bloodhound's surface, you'll find tiny holes, which lead to a plastic pipe and a pressure sensor. These are key to understanding the aerodynamics of the car. Although Bloodhound may be doing 1,000 miles per hour, there'll be some areas where the air is travelling much more slowly, and some where it's travelling much faster. Strain gauges use electrical resistance to measure how much an object is deforming, and consequently how big a load is going through them. They're attached to all the critical parts of the car where we expect to see the very highest forces, like on the suspension and fin. When you've got a rocket, a jet, and a large supercharged engine in a confined space, it's going to get hot. So temperature sensors will make sure we're operating within a safe temperature range. There are also humidity sensors to make sure the many computers are dry, accelerometers to measure vibration and resonant frequencies, a pitot tube to measure airspeed, sensors that measure the wheel's rotation and movement of the suspension, sensors to measure fluid level so we can tell how much fuel is being used, lasers to measure the ride height, cameras to give us visual information, GPS to measure the ground speed and keep all the computers in sync, telemetry that records the driver's actions, and finally the driver himself. Thanks to Oracle, all this data will be shared live, so you'll be able to experience Bloodhound as if you were in the car too.
I would say that was fast.